Okay, this is part 2 of the interim practice tests that you've had for half-term homework. Okay, so starting on question 4 now, express 3x squared minus 12x plus 17 in the form ax plus b all squared plus c, where you need to find the values of a, b and c and sketch the graph of the stationary points. Okay, the first thing to notice is that thing there is literally identical to that thing there, so you don't have to do anything fussing around with that. So whatever we find now is what we need to find for the next bit. Okay, so okay then. So originally for number 4, working there. Focus that a bit better. There you go. Originally for number 4, we're given that we have 3x squared minus 12x and then plus 17. Okay, so what we do is we ignore this 17 altogether. We're just going to take 3 out as a factor. So we get 3x squared minus 4x, and then we get the plus 17 there. Okay, try and fix that a bit better again. There we go. Okay, so what I do now is I open up a double bracket, but it's very important that you do the next bit inside here. This is where the most common marks are lost. We halve this coefficient here, so we get x minus 2. Drop the x from that point and drop the squared from there, and put the squared out here. Okay. Now, if I did go and expand that out, I get x minus 2 multiplied by x minus 2, which will give me x squared minus 4x plus 4. Okay, so that's giving an extra plus 4, which I didn't have by here, so I need to take away that 4 here. But the shortcut is say take away whatever this value is squared, and it will just get rid of that bit there. Okay, that's just a bit of side working just to talk through why we do that, and then we get plus 17 here. But the key thing that you got to do is you do have to times this minus 4 by the 3 there. That's where people forget to do that and they get it wrong. Okay, so now what I'm going to do is expand the 3 by that, so I get 3x minus 2 all squared minus 12 plus 17, which is then equal to 3x minus 2 all squared and then plus 5. So in terms of finding my constants a, b and c, well they're there. You don't need to actually go out and say a equals 3, b equals, in this case it said a plus x plus b. If I look at the question there, now I've actually gone and found that I've got a negative answer there. That doesn't matter, b is just negative 2, and then c would be 5. We don't need to write that box, but if you want to just have it down in your writing so it looks all nice and perfect, then by all means. In terms of drawing what that looks like, this is where a lot of you lost a mark in this assignment. So if I just draw my quadrant, it should just be, you know, quick drawing here. There's nothing that's taking a lot of time. I know the minimum point from here, whatever makes this 0, so x equaling 2, 2 take away 2 would make that 0, and then y is whatever is left here, so y is equal to 5. So that's what we call our stationary point, or our minimum point in this case, because it is a positive x squared, it's 3x squared, so that would be 2, 5. So I go and plot that, 2, 5, doesn't have to be to scale, and I know it goes through the y-intercept at plus 17. So when I'm drawing that, it needs to go through that point there, and I need to specifically say that's 17. That's what a lot of you didn't do on your homework, and I took a mark off for it. Okay, so for question 5, so if we have a quick look, what it says for question 5, given that the quadratic equation, this thing here, is equal to 0, it has no real roots, show that 3k squared minus 2k minus 16 is greater than or equal to 0, hence find the ranges of values satisfying k in the inequality. Okay, so basically what this means, we're used to seeing things in the form like ax squared plus bx plus c equals 0, and it's just saying that if you've got a value here that's affecting the a coefficient and it's affecting the c, what are the values that you can have so that when you draw your graph, it has no real roots, i.e. here's my x-axis and here's my graph. It doesn't actually go down, touch the graph. If it touched the graph once, it would have one real root, and if it overlapped, so it came like by here, that would have 2 real roots. Okay, so that's got no real roots, but this one would have 2 real roots. Okay, so what I need to do is I need to use something called the discriminant. So for question 5, I would state, first of all, I'm going to state what A is, what B is, and what C is. So A is 3k minus 2. You don't have to put it in brackets, I'm just putting it in like it is in the question. B is positive 8 or just 8, and C is positive K or just K. Now, because we've got three different types of discriminant, it'll always be B squared minus 4AC, B squared minus 4AC, and B squared minus 4AC. If it is greater than 0, you get 2 real roots. If it is equal to 0, you get 1 real root. And if it is less than 0, you get no real roots. And that's because that's the bit of the quadratic formula. It's where you've got minus b plus or minus b squared minus 4ac. And if you square root a positive number, you get 2 answers. So like square root of 9 is 3, but it's also minus 3. Square root of any positive number will always give 2 different answers. Okay, and that is because you've got a positive number. If it is equal to 0, then the square root of 0 is 0. There's only one answer, hence 1 real root. And if you have a negative answer, you can't actually square root a negative number. If you go and put it into your calculator, the square root of minus 9, it'll say math error. Because whenever you square a number, any number, no matter what it is, it's always positive. Think about the shape that we just said for quadratics. It does that shape. So you don't actually go into the negatives. Okay, square root of 9 is 3 or minus 3, as we said before. Okay, so the fact that I'm told it has no real roots means that I want to use b squared minus 4ac is less than 0. Okay, now the one thing to notice here, if I go back to the question, it says here's greater than 0, but don't let that affect you. You've got to know these, you've got to learn these things here. Okay, so I now need to sub into this. So b squared, so that's going to be 8 squared minus 4. Now definitely keep this in brackets, or you'll most likely mess it up. And then k is less than 0. Next thing I'm going to do is I'm going to answer that. I'm only going to expand this bracket for now. I'm not going to do the minus 4 as well. So I'm going to get 3k squared minus 2k. And now I'm going to expand. So I'm going to get minus 12k squared. Minus 4 times minus 2, though, is plus 8k. So careful for that as well. I'm now going to write it in the form of ax squared plus bx plus c. But in this time I've got k's. So I've got minus 12k squared plus 8k plus 64 is greater than 0. Okay, so if I go back and look at the question, it's not looking quite like theirs. They've got 12, 8 and 64. I don't want this to be negative, so what I'm going to do is think of a factor that goes into all of those. So I'm looking at that and thinking, well, certainly 2. Now half of 12 would be 6, and then it goes down to 3, so to 4. Okay, so I'm going to divide through by minus 4, but whenever I divide by a minus number, then that automatically flips that inequality straight away. So I'm going to write that in straight away. Okay, minus 12 divided by minus 4 would give me positive 3k squared. A positive divided by a negative will give me a negative 2k here, and also a negative half of 64 being 32, half of 32 is 16, and lo and behold, I've got exactly what they needed. Okay, I've got that bit there. What I need to do now is go and solve that inequality. So using our trick of timesing the front number by the back number, we get minus 48. 3 times by minus 16 minus 48. And they must add to minus 2. So I'm thinking of a pair of numbers at times to be a negative number. So that must be a positive and a negative answer. What they are, I've got absolutely no idea. I need to just have a guess. So 48, 12 and 4. 12 take away 4, well that's equal to 8, so that's not minus 2, that's no good. What about 8 and 6? That gives 2. Now we're close now, I need to get negative 2, so I just need to swap over those two numbers, so I get 6 and minus 8, and that is equal to minus 2. Bingo, that's my pair of numbers. Okay, so what I do now is I write double brackets, it's greater than 0, and I just drop just the squared term from that k, just put 3k in front of those, and then plus 6 goes in one, and minus 8 goes in the other. Okay, but if you're going to use this trick, you must cancel down when you can. I can clearly cancel down the front bracket to being k plus 2, dividing top and bottom by 3, and it just goes using this trick. This one here, there's not a number that goes into 3 and 8, so that remains as 3k minus 8 is greater than 0. Now I do my check, k times 3k would be 3k squared. If I multiply the back 2's together, plus 2 times minus 8 gives me minus 16. If those two match, I bet you it would match up to give me that as well. Okay, so I've got a quadratic here. So if we look back at our shape of our quadratics, we know we're doing that. I've gone and found what its roots are. That would be a minus 2 by there. and this would be 8 over 3 just by solving those, by taking them over. And I'm only interested of where it is bigger than 0. So it's bigger than 0 here, and it's bigger than 0 here. Okay, so it's going to give me two disjointed inequalities. My first inequality, k, must be less than -2, and k must be greater than 8 over 3. Okay, so what that really means is that if I did go and chuck in a number for k that was less than -2 into this original thing here, so say I chucked in like -10, I get -30, -32x squared plus 8x, and then -10, I'd expect that to have no real roots. Okay, and likewise, if I chucked in a number that is bigger than 8 over 3, so that would be 9 over 3, for instance, which is 3. If I chucked in 3 into that, I'd have, what, 3 times 3 is 9, 9 take away 2 is 7, 7x squared plus 8x plus 3, again, I'd expect it to have no real roots. However, if I chucked in a number in between these two, so say like 0 or say 1 or whatever, let's chuck in 1 there. 3 times 1 would be 3, take away 2, so that would just be 1x squared, or just x squared, plus 8x plus 1. I'd expect 8x squared plus 8x plus 1, I'd expect that to have at least one real root, maybe even two real roots. Okay, so that's what that does. Okay, then going on to the back page now, and looking at question 6 and 7. So question 6 was a differentiate from first principles. So I've just marked assignments on that, and they were done very, very well. So it comes up every year. Just a little bit of order that some of you need to put to your work. First of all, you say y equals 7x squared plus 5x minus 2. Okay, so that's our first equation. Now, effectively, what we're doing, if we've got that, then as a quadratic, if I pick a point here and I pick another point there and I just join them up, what that does is it creates what's it called? It's called a chord, is it? I think it's called a chord. The closer this gets to that point, as that gets closer and closer to that point, it is going to get closer and closer to what the curve is. Okay, so if I had said that that was like x equals 2 here and x equals 3, there's obviously a difference of 1 between those two. But here now, if that's x equals 2 and that's equal to 2.1, then the closer that gets to being 2, the closer that that chord is getting to be what the actual curve is. Okay, so what we say is, we say y plus delta y, which means a little bit of y, because as I've gone up in x, I've gone up in y's, is equal to 7, and wherever we see x, we change it to a delta x squared, plus 5, and then the x plus delta x minus 2. Okay? Now you must expand out any brackets here. Now I'm just going to take my time doing this, I'm not going to rush it. And just say what squared means. It means times by itself. And if I expand this one here, I get 5x plus 5 delta x, and then I just get a minus 2 there. Now I'm going to probably do a little bit of work just to save me some hassle. Using a different colour pen. I don't know if this is different though. So this would be actually no. Yeah, it's different. It would be 7x squared plus, and we're going to get an x plus delta x here, and then we'll get another x plus delta x here, which is going to give me 2x delta x plus, and we say delta x all squared in a bracket, so you don't think it's just the x that's squared, it's the delta x that's squared. Okay, plus 5x plus 5 delta x minus 2, and then eventually we're going to get y plus delta y is equal to 7x squared plus 14x delta x plus 7 lots of delta x all squared plus 5x plus 5 delta x minus 2. Okay, but you can get quite quick at expanding this thing here. You should know after the assignment that that is that blue line of work there, and you can maybe skip these lines here and jump straight to that. Okay, so that's our second equation. Some of you didn't do the assignment. It's not strictly speaking wrong, but it's not a great way of showing your work. Is that you want to say equation 2 take away equation 1. It's like simultaneous equations now. Okay, so anything that is in this original one, you're basically going to remove from here. So y plus delta y, take away y, is going to leave me with just delta y. Okay, and then the 7x squared is gone because it's in both, but it'll leave me with 14x delta x. I'm going to have plus 7 delta x all squares, and then the 5x is going to go because it's in both, and then I'm going to have plus 5 delta x, and then minus 2 minus minus 2 is going to go. Okay, now the one thing you should notice is that every part of this has delta x in it. So if I divide both sides by delta x, it will remove delta x as long as it is only there once. So I'm going to get 7 delta x here, okay, but plus 5 here. Now the next line that is crucial to get a mark for, if you don't write it, you won't get the mark. You say dy by dx is equal to the limit as delta x tends towards 0. Okay, now that's this bit here. So I'm saying it's that bit getting closer and closer and closer to what that was originally. So as that tends to 0, we get what our differential is. Okay, so delta y over delta x. So dy by dx is equal to 14x. That delta x is tending to 0, so that means 7 times 0 is nothing, but I've still got a plus 5 on the end. Okay, and as you should know, as your from your knowledge of differentiating, then we times by the power, so 7 times 2 is 14, and the power decreases by 1, and same by here, power, which is 1, times by 5 is still 5, power goes down by 1, so in our case now it would be 0, anything to the power of 0 is 1, so 5 times 1 again is 5. Okay, so we know that's correct, so you should use that to help you here. For part B, before you write this, you must write it in indice form. So we'd say 2x to the minus 3 plus 5x to the 2/3. Now I'm going to differentiate that. So to say that, I say d by dx, that tells me I'm differentiating things. And I'm going to get times by the power to get minus 6, x to the minus 4. The power must decrease by 1. It's already on minus 3, going down 1 from minus 3 gives me minus 4. The next one here, I'm going to get, now it is going to be a plus, isn't it? Because I'm timesing that by 2/3 and that's already a positive. 5 times 2/3 would be 10/3 x, and then that would go down by 1. So I'd be basically just taking 3 off 2. So 2 minus 3 is minus 1, so it'd be minus 1/3. And that is absolutely fine for your 2 marks. You can neaten it up a little bit if you wish. You could say that's minus 6 over x to the power of 4 plus 10 over 3x to the 3rd. Okay, but as I'm not being asked to sub into anything, we don't have to do that step. This would have been fine for 4 marks. Okay, and then finally for number 7. So 30 marks here, so quite a lot of marks available for this one. And what have we got here so far? Number 7. Okay then, so we've got y equals 4x cubed minus 12x plus 3. It says find the coordinates. So if I get the question in front of me here, it says find the coordinates of the stationary points and determine the nature of these points. Pretty standard for us now. We know that stationary points occur when your differential is equal to 0. So that means we need to differentiate it. We then need to put that equal to 0 and then solve it as an equation and find our x values. Once we find our x values, we will sub those into y to find out what their y values are, and then we will double differentiate to find out the nature of the points. Okay? So, first bit, dy by dx is equal to 12x squared minus 12. So I'd say stationary points or stat points is fine to shorthand to that. Stat points equals, I'm going to say put an arrow there and say 12x squared minus 12 is equal to 0. So basically now it's not a normal quadratic in terms of having 12x squared plus something x plus or minus something. I just need to get x on its own. So 12x squared is equal to 12. So x squared is equal to 12 divided by 12, which is 1. So x is equal to the square root of 1, and be careful, x is equal to plus or minus 1, as we talked about earlier. Okay, so I'm going to now say when x equals 1, y equals 4 lots of 1 cubed minus 12 times by 1 plus 3. So that's going to give me 4 minus 12 plus 3. 4 plus 3 is 7, 7 take away 12 is minus 5. So there's my first set of coordinates. We've got 1 and minus 5. Okay? And for when x is equal to minus 1, y is equal to 4 lots of minus 1 cubed. Minus 12 times minus 1 plus 3. So y equals, so minus 1 to the power of 3, it's going to be minus 1 times minus 1, which is positive 1, but then times by minus 1 again is going to go back to being negative. So it's going to be negative 4. If it's ever to an odd power, always a negative. If it's an even power, always positive. Minus 12 times minus 1 is plus 12, and then plus 3. So 12 plus 3 is 15. 15 take away 4 is 11. Okay, so there's my other set of coordinates there. So I've got minus 1, 11. For the next part, oh, hang on, I haven't done my nature yet. So the nature of my points, I do d2y by dx squared. That means I'm double differentiating. So go back to dx, dy by dx, 12x squared. That's going to give me just 24x. Okay, there's no x part in there, so that just goes. So I'd say when x equals 1, d2y by dx squared equals 24 lots of 1, which is equal to 24, and when that is a positive number, it's the opposite of what you'd expect. So you'd say that's greater than 0, therefore it is a minimum point. Okay. Whereas when x is equal to minus 1, d2y by dx squared is equal to 24 times minus 1, which is minus 24, which is less than 0, which is therefore a max. Okay, so I've got my 7 marks now. I've done all of those bits. I now need to sketch my graph, which I'll just do very, very quickly over here. So I go and plot the points first. So minus 1 and 11, so roughly there, minus 1, 11, and 1 and minus 5, so that would be 1, minus 5 here. Okay, now because this is a maximum point, I can draw my little curve like that, my little curve like that. Where does it cross the axis? It crossed it at plus 3, looking back at the question. So that needs to go through there roughly. Okay, and then through here. So here it's tending towards positive infinity, here it's tending towards negative infinity. For the next question, they can give you load of different things. We've seen it with equal k's and stuff like that. Here they've actually asked us to do some transformation of graphs, which is actually something you get taught in GCSE, and it does come up again in C1. We've got a little bit more to do on it after the half term. So it says given that f of x is equal to 4x cubed minus 12x plus 3. That's the thing that we've just drawn. Given that it's basically this. This is what we can call f of x. Sketch the curve y equals f of x minus 1, indicating the points of indicating the coordinates of each of the stationary points. Okay, so the rules that you need to recap and make sure you know is f of x plus a, f of x minus a, f of x plus a, and then f of x minus a. Okay, now this one here, when they're outside the bracket, it does what you expect, and it either moves it up or it moves it down. Okay, when it's inside the bracket, it moves it left or right instead, and it does the opposite of what you expect. So if I was adding 1, I'd expect to move 1 across this way, but because it does the opposite of what I expect, it moves this way. Whereas this one here, you expect subtracting 1, you expect to move backwards 1. It does the opposite of what you expect. Okay, there's also a couple of other rules you've got to remember, where you've got like minus f of x, f of minus x, and a f of x, and f of ax as well. But we'll come to those at some point. Okay, this was from GCSE. I'd expect you to be able to recall this without too much hassle. So same quadrants. It's going to move this graph now. Minus 1, I'd expect it to move backwards 1, but it does the opposite of what I expect, so it's going to move to the right 1. Now, if that moves to the right 1, that minus 1 is now become 0, 11, and this 1 is now going to become 2 minus 5. Okay, so basically, my graph will look like it did before, but just moved over to the right. So now, this point would be 0, 11, and this point here would be 2 minus 5. Okay, that concludes the tests, and there were 60 marks out of a possible 75 on a C1 paper. So that is equal to 80% without looking at 3 topics, which is equal to an A. So if you got all of those without even doing the other 3 topics, you're already working at an A grade standard. Well done.